Hello, my name is Stephanie Lilia. I'm a PhD student at the University of Vienna at the Department for Nutritional Science, and I will present you my abstract about our study fasting and fasting mimetic supplementation, address sirtuin expression, microRNA, and microbiota composition. Shortly to the background, it is known that fasting, like interval or periodic, has a positive and great impact on our health. Nevertheless, so-called fasting mimetics are of growing interest, which can mimic the benefits of fasting, and sirtuins, increased health span, and longevity are a hot topic regarding caloric restriction. In our study, we compare Buchinger fasting with a supplement intervention group containing secondary plant ingredients known to activate sirtuins or act as a fasting mimetic. Thus, our study is divided into three different groups. The fasting group, and containing 20 people, which were fasting for 5 days, periodic, and with a maximum intake of 250 kilocalories a day. And we had the supplementation group, which was divided into the active and the placebo group, which was at the same time our control. So 100 participants consumed the active supplement, a shot, for 3 months, 1 falcon a day, 25 milliliters. And 31 were at the placebo group, which was randomly picked and was blinded, so they did not know which supplement they were using or were drinking. We collected dried blood spots and stool samples at the beginning and at the end of the interventions. In our study, we assessed relative telomere length, mRNA, especially sirtuins, and microRNA expressions. But we also determined the microbiota and short-chain fatty acids which they produce, because we know that the microbiota has also a major impact on our health, and sirtuins can also be expressed in the gut. So we did not want to neglect this important part and interaction for our health. Moreover, for the fasting group, but only for the fasting group, we also measured ketone bodies. At the baseline, we saw that relative telomere length decreased with age for all the participants, and telomere length positively correlated with SIRT1 for the fasting intervention, and positively correlated with SIRT6 for the supplementation intervention. We did not see any changes in relative telomere length before and after the interventions, but we saw that both interventions could increase SIRT1 expression. And although the ketone bodies raised until 5.4 millimolar in the fasting group, and we know that SIRT3 is involved in the ketone body production in the liver, we were assuming that we will see a significant increase in SIRT3, but we could only see a trend. We assumed that 20 people were at too small population size. Nevertheless, we saw also a switch in the gut composition at the phylum levels. So firmicutes decreased in the fasting group, and butyrate significantly increased, which seemed to be produced by tenoricutes for our population. A decrease in firmicutes could also be seen in 2 other studies for a fasting intervention. In the supplementation group, actinobacteria significantly increased. Actinobacteria is also a phylum which is a butyrate producer, and moreover, bacteroidetes interacted with microRNA 16 and microRNA 125, which is usually downregulated in participants with irritable bowel syndrome. So our outcome would assume that the supplement has positive impact on the intestinal barrier function. To conclude, our results show parallels between fasting and the supplementation of secondary plant ingredients regarding increased health span and longevity involved mechanisms. Thank you for listening.